Energy is the capacity of a physical system to perform work. It is located everywhere around us in many different forms. We use it to perform our everyday activities from powering our cars to lighting our homes. It cannot be destroyed or created. So where does this energy come from? The answer is that we transform energy found in nature into a usable form. This is done in many ways, from burning fossil fuels to, of course, tidal power. To understand tidal energy, you must first understand how tides work. Tides are changing water levels caused by the gravitational forces between the Earth and the Moon, as well as the Earth's rotation in orbit. The rotation of the Earth and the Moon are elliptical, and thus not completely circular. As a result, there are certain times of the day in which the Moon will be closer to the Earth than at other times. This creates a gravitational pull on the Earth's water, causing it to rise. This is known as high tide. When the Moon is farther away at other times, the gravitational pull is weaker, and as a result, the waters recede, which is known as low tide. Tidal energy is the energy obtained from these changing sea levels. The tide, moving from high to low points, generates massive amounts of kinetic energy. This kinetic energy can be used to convert into electrical energy. To harness the power of tides, you must first build a dam or barrage across a tidal zone. Tidal zones are areas of the shoreline in which tidal forces are great. The constant movement of tides moving up and down spins turbines connected to a generator. The spinning turbines generates rotational mechanical energy, which is used as input energy into the generator. Within the generator, there is a loop of wire with magnets, which is used to generate the electric current. Thus, the vast energy stored within the power of tides is converted into electricity which humans can use. This is very similar to how hydro and wind power are harnessed. However, in tidal energy, the turbines are much smaller but much stronger. Another way to harness tidal power is to gather rising water within a chamber. The rising water forces air out of the chamber, which in turn spins the turbine connected to a generator. When low tide occurs and the waters recede, air is pushed back into the chamber. Another way to harness tidal energy is to gather rising sea levels within a reservoir and preventing it from escaping. After this, the water in the dam can be used just like any other hydroelectric power plant. Every tidal energy plant uses one of the above methods of gathering tidal energy. There is variation between each, but the general idea remains.
The history and development of tidal power extends centuries to the past. Mills powered by tidal energy have been known along the coast of France since the 12th century. Much later, American colonists built tidal-powered mills in New England. The early tidal mills used the great mechanical force of the tides to turn water wheels connected to grain stores. By 1967, tidal energy technology had so advanced that engineers were able to complete the world's first tidal electric plant. Not coincidentally, the plant was again situated in Britain, this time at the Rance River. The maritime estuary formed where the Rance meets the English Channel is known for its exceptionally large tidal range, which reaches 44.3 feet. The 240 megawatt low range facility is essentially a huge dam with a hydroelectric power plant inside. The dam completely seals off the Rance estuary from the sea, impounding up to 6.5 billion feet of water. When a rising tide comes into the shore, water passes through main gates in the dam, filling the estuary and powering hydro alternators. By closing the main gates, the plant operators can trap huge masses of water in the tidal basin behind the dam until the height of the water on the sea side of the dam has dropped considerably. Then, the main gates can be opened again, allowing the water to spill back across the turbines to the sea. Through the use of specially developed reversible turbines for lower Rance, electricity can be generated each time water travels the dam. The advantages and disadvantages of attaining tidal energy. Firstly, advantages. Once tidal power plant is built, it does not cost more to produce electricity. It does not emit greenhouse gases, carbon emission gases which pollute environment. It does not have any dependency of any fossil fuel including furnace oil, gases, etc. It needs no oil whatsoever to produce electricity. Tidal power technology is renewable energy, which uses tidal and waves of some water for producing electricity over and over again. Tidal power plants does not require much maintenance, therefore its maintenance cost is low. Tidal energy stations have about 80% efficiency ratio, whereas fossil fuel have approximately 30% for efficiency levels. Tides in oceans are very predictable. It's easy to judge when strong tides are going to show up from water, consider weather and other conditions. The better tides and wave strengths of the ocean is, improved the efficiency of the station is. Electricity does not fluctuate on large scale using tidal energy as it happens in solar power technology. The disadvantages of tidal energy station. Tidal power plants are not cost effective. Millions of dollars are utilized for developing tidal power, which could provide electricity in megawatts. It causes some sort of environmental changes and destruction beneath and upstream on interior area covered by tidal power plant. There are not many places in the world where tidal power plant can be built. It needs ocean, which provides certain flow of waves and tides of water. Tidal power plants can only be built in water. It cannot be built on inland area like solar power plant, wind power plant, etc. Electricity can only be produced when tides are high in the sea. Once the ocean is calm and does not flow certain levels of waves, it cannot produce electricity. Therefore, electricity can be produced for only 10 hours a day in the presence of tides. Barrage installations is tough task, as even single part of the entire turbine is required to be placed in appropriate position. Barrage systems are required to be salt resistant part, as it is always remain underwater. Wings of turbine inside water can affect life underwater and in some cases can produce distractions on the way of ships passing through the area around tidal power station. Electricity produced using tidal power station is on expensive side when it is compared with conventional ways of producing electricity, for instance with oil, coal and natural gas.
Tidal energy, the world's most reliable energy source. Twice a day, and every day since the world began, the oceans produce powerful water currents and tidal movements that are so reliable they can be predicted years in advance. For centuries, mankind has sought to exploit this massive source of potential energy. In Roman times and the Middle Ages, mill wheels driven by flowing water were used extensively for grinding wheat into flour. Until recently, there has been little development in our ability to harness this huge resource of power. Today, the wonders of modern technology have allowed us to extract this huge potential of raw energy for the production of electricity without harming the environment. So why the focus on tidal energy? The world has an increasing insatiable appetite for power. Global warming is compelling us to move away from fossil fuel and other high-risk fuels to clean, green, renewable sources. What are the advantages of tidal energy? It's renewable and sustainable. Seawater is 832 times denser than air, which means an 8-knot tidal current has more energy than a 380 km/h wind. Once a turbine is installed, tidal energy is free. No expensive fuel is required. It has a very low maintenance cost. Tides are predictable many years in advance. There is no impact on the visual amenity as tidal turbine is underwater. It is the most energy dense of any renewable energy source. It produces energy for the lowest cost.